Hey guys, so today we're going to talk about transformations of functions, pretty much your parent functions, and we're going to have a few examples. Right now it looks like I've written a ton of stuff on my screen, but I guarantee you it's all important, and we'll go talk about it right now. So what we've done is we've taken our basic function, y equals f of x right here, and we've pretty much transformed it as many ways as we possibly can with using variables over here. So we've got y equals a times f of bx minus c plus d at the end. And now let's just go variable by variable and describe what each letter would do. So first let's start with a. If that implies a vertical stretch or shrink, and if the absolute value of a is greater than 1, we have a stretch. And if the absolute value of a is less than 1, we have a shrink. And then b is going to imply horizontal stretch or shrink. And so if the absolute value of b is greater than 1, it's a horizontal compression. So it's kind of the exact opposite of the vertical, where greater than 1 implies a stretch. For this one, if b is less than 1, it implies a stretch, not a strength. Oops, stretch. Okay. So then we finally have this c value over here, and that's just the horizontal shift, shows how far it goes left or right. And if c is less than 0, we're moving to the right. If c is greater than 0, we're moving to the left. So if it's like x minus 4, we would move to the right 4. And if it's x plus 4, we'd move to the left 4. So just think about it, it's kind of like the opposite of what you would think. And then we have d value, which is the only one where it's exactly what you would expect. You just go up or down by that amount. So if d is 3, you go up 3. Alright, so now that we've done all of that stuff, well, also let me mention the x-axis reflection and the y-axis reflection stuff. If the negative is in front of the f of x, so if it's just like way out here, if we have y equals negative x, then it's going to be an x-axis reflection. But if it's y equals f of negative x, where it's attached to the x, like right there or something, then that would make it a y-axis reflection. And just pay attention, we have to like the problem, and you'll be able to figure out which one we're working with. Okay, so now let's look at some examples instead of looking at this confusing jargon. Let me get a pin out, and let's go. So what we're doing is I've drawn in the parent function. So we're given this y equals x cubed, and now we're transforming it to y equals x plus 2 cubed minus 4. Okay, so immediately I notice, well, the only thing that's changed is we've got this plus 2 and we've got this minus 4. And I always like to start with the down 4 because I just know that that's like the easiest one, so I can say, well, we definitely went down 4. Okay, now what's our other transformations? Well, what does that plus 2 do? Let's think about it. That changed our c value, and here we have, well, is c greater than 0? Yes, it is. So we're going to move left by the value of c. So we're going to move left 2. Left 2. So we're going down 4, left 2. And you can think about the c value, because it's positive 2, we're going to go to the left. It's kind of like the opposite of the sign. So if it's positive 2, you'd say right, but it's actually left. So that's an easy way to remember as well. Just do the opposite. Okay, so we started at 0, 0. Because it's a cubic function. So that's how I would like to start my transformation. And I'm going to go down 4 from that point. So 1, 2, 3, 4. Then I'm going to go to the left 2. 1, 2. So I know my new starting point, per se, is going to be right here. And the shape of the cubic function has not been changed by this transformation. It's still going to look like a normal cubic. So that means it's going to be going down to negative infinity here. Then it's going to flatten out a little bit. And then it's going to go back up to infinity. So that's, in general, what our new cubic function, y equals x plus 2 cubed minus 4, would look like. Alright, now we've got an interesting one here. We've got y equals x squared, which is drawn in the white. Then we're saying y equals 4x squared. So what has changed? We've just got this 4 out front, and let's look back. That's changing our a value, so it's going to be a vertical stretch or a shrink, and a is greater than 1, the absolute value, and so that means it's going to be a stretch. And now what this confuses a lot of people, and what I like to think about it is if you stretch something out, it normally gets taller. So like if you as a human were stretched to be 7 feet long instead of 5 feet, you'd be taller, right? And you'd be skinnier. So that's exactly what happens here. However, if you were 5 feet tall, then you were shrunk to 1 foot, you would get larger, you'd get fatter. So that's what happens exactly with graphs. So if we're being stretched by 4, we're going to get skinnier. So what's going to happen is we're going to go up like this. The shape will still in general be the same, and then we're going to go up like this. we've been stretched by a factor of 4, so now we are taller. We're taller and skinnier. I hope that makes sense. That's the only way I was able to really remember these. So anytime that the a is positive, we're being stretched. Alright, and now we've got this one. We've got, okay, y equals the square root function, and then we have y equals the square root of negative x. Okay, so I know that this is going to be one of my reflections. Do we have y equals negative f of x, or do we have y equals f of negative x? Because that'll change the reflection. Well, let's think about it. What would y equals negative f of x look like? That's when you just put a negative out front. I think that would look like y equals negative square root of x, and that's not what we have. So we obviously have the y-axis reflection, and what axis is the y? Well, that's the one that goes up and down. So y-axis reflection right here, just going to do a mirror image, so it's going to look like this, and that'll be it. And if you wanted to, you could plug in values. So if we have, now we could plug in, and the function wouldn't exist on this side, and that's because, say we had y equals, if we're doing, we'll say x is 1, so we're looking for this point right here, 1, we'll get y equals the square root of negative x, which is 1, negative 1, that doesn't exist, can't be a point. So that shows you that your domain cannot exist on the positive x side, so the y-axis reflection was correct. I hope this was able to help. You should take these notes and just study them, and eventually it'll be like second nature to you, and you'll be able to do these transformations like nothing. Thanks for watching. Hope this was able